Today we will learn the areas under the curves. So how the definite integral concept is used to find out the areas of different curves. Okay, so areas under curves. The area of the region bounded by the function y equals to f of x continuous in a to b is integral a to b f of x dx. So how do we get this? So for example, if you take y is equals to f of x curve, y is equals to f of x curve, this is origin, y, negative y, x dash x. So let us take this point which is at a distance of x units from the origin. Then this is the y component. So simply this x, if you substitute in this, then we will be getting f of x. This point is f of x. That means this height we get f of x. So if I go a little bit further and take this rectangle's width to be a small change in x. This is, for example, dx. If I take, what is this? Dx if I take, then the area of this rectangle, this would be dx into f of x. So area is equals to this is f of x into dx. This is actually f of x into dx. And if you want to find out the area of the region bounded by the curve y is equals to f of x, this is x equals to a and this is x equals to b, then it would be integral a to b f of x dx. So this gives the definite integral. So with the help of this, we will be discussing the various areas. First one, the area of the region bounded by y is equals to f of x, where f of x is greater than 0. That means above x-axis. That means above x-axis, x equals to a, x equals to b, and x-axis is given by area is equals to integral a to b f of x dx. So it would be like this. So this is y is equals to f of x. This is x equals to a. This is x equals to b. And x-axis. So this area is equals to integral a to b f of x dx. Since f of x is positive, that means above x-axis. So this is y is positive, this y is negative. So here f of x is greater than 0. Likewise, the area of the region bounded by y is equals to f of x. Here f of x is less than 0. That is, this y is equals to f of x is lying under the x-axis. So x equals to a, x equals to b is given, and x-axis is given by area a is equals to integral a to b minus f of x dx. So that means the diagram of this would be like this. So this is origin, this is negative x-axis, positive x-axis, y, negative y. So this time, this is the y equals to f of x. Here, f of x is lying below the x-axis. Therefore, this is x equals to a, this is x equals to a, and this is x equals to b, and this x-axis. Therefore, x-axis, x equals to b, x equals to a, and this is y equals to f of x. This is the area of the region bounded by the curve. So, if I club these two together, then the area can be written as a is equals to integral a to b f of x dx modulus of f of x dx. Let us not confuse with the definite integral and the area. So, for example, if you are asked to find out the area of the region bounded by y is equals to x cube between minus 1 to 1, then so definite integral is equals to integral y dx, integral y dx. So y is a function of x. So this is x cube dx between minus 1 to 1. This is equals to integral x cube dx is x power 4 by 4 from minus 1 to 1. This is equals to 1 by 4. X is 1 power 4 minus the same x is minus 1 whole power 4. This is equals to 1 power 4 is 1 minus 1 power 4 is also 1. 1 minus 1, 0 by 4 is 0. But this is not the actual area. This gives the effective area, because if I try to plot the diagram of y equals to x cube, which we will be learning the properties and the behaviors, how how to sketch the areas roughly. So we know. So we will get that later. But for the time being, y is equals to x cube. The area of this, the diagram of this will be like this. So this is minus 1 and this is 1. So now the area is this area. This is 1. But if we see here, then actually the area we will be getting some area other than 0. But here total 0 is what we are getting. How do we get? So this area is nothing but, so which we have discussed before. This is y equals to f of x, x equals to a, x equals to b, and x-axis. This area is positive, and if it is negative, so this is y is equals to f of x. So here this area is integral a to b f of x dx, and here in a to b minus f of x dx modulus will be here. So if I take this minus 1 to 0 f of x dx, plus 0 to 1 f of x dx. So minus 1 to 0 f of x is minus x cube, since this is below the x-axis, dx, plus here 0 to 1, minus 1 to 0, 0 to 1, 0 to 1, this is plus x cube dx. Why plus here? The concept is this is above x-axis. So now let us see what will happen. So will we get actual 0 or other than 0? Because actually we can sense here, we can see that the area is not 0 according to the diagram. So let us see here. So minus x cube dx is minus x power 4 by 4 from minus 1 to 0, plus x cube dx is x power 4 by 4 from 0 to 1. So minus 1 by 4 separated, x power 4 0 minus 1 power 4 is upper limit minus lower limit, minus lower limit is minus 1 whole power 4 is plus 1 into minus 1. So 1 by 4 into this is 1 power 4 minus 0 power 4. So this is minus of minus. So 1 by 4 plus 1 by 4. So 1 by 4 plus 1 by 4, 2 into 1 by 4, which is 1 by 2. Actually this is the actual area, but here according to the definite integral property we are getting 0. This is the effective area. So everything it will give the raw area rather than the actual area. Therefore the area of the region bounded by the curve, this is y is equals to f of x. This is A and this is B. In between this is C. So this area plus this area is equals to, area is equals to A to C f of x dx plus C to B f of x dx. If I keep a modulus here, then this gives the actual area of the region bounded by A to B. If the modulus, if we are deleting here, then actually this is a definite integral. Sometimes it may give 0 as well, but the area is not the 0 here, because actually we can see some area is what we can sense here by the drawing this diagram. Likewise, the area of the region bounded by the curves y is equals to f of x, comma y is equals to g of x, where f of x is greater than or equals to g of x between the limits x equals to a, x equals to b, and x-axis is area is equals to integral a to b f of x minus g of x dx. That means the situation here is like this. This is y is equals to f of x curve, and this is y is equals to g of x curve. Between x equals to a and this is x equals to b. So this area we are trying. Simply here f of x is greater than g of x. So upper curve minus lower curve dx. The next one is the area of the region bounded by the curves y equals to f of x, comma y equals to g of x, and x-axis. So, for example, this is, so this is something like this. There are two curves. This is x equals to a, this is x equals to b. So this is f of x curve and this is g of x curve. So y is equals to f of x curve, this is y equals to g of x curve, and this is, for example, b, x equals to c. C is lying in between a and b. So here f of x, y equals to f of x, y is equals to g of x. So f of x is lying in between, f of x is greater than g of x in a to c, and why f of x is greater than g of x? Here f of x is a dominating curve and this g of x is lying below f of x, and f of x is less than g of x in c to b, and x-axis is given by area A is equals to integral A to C, here f of x is a dominating curve, g of x is a below curve. So this area is A to C, f of x minus g of x, f of x minus g of x dx plus C to B, this time g of x is a dominating curve and this y equals to f of x is a lower curve. That is why f of x is less than g of x in the interval c to b. So this is c to b, this area is c to b, g of x minus f of x dx. Likewise, the area of the region bounded by x equals to f of y, and the lines y equals to c, y equals to d, and y axis is given by where f of y is greater than 0, x is equals to f of y. Otherwise, g of y also we will take, no problem. Function of y, that is said to be, that's it. So this time this is the situation like this. This is x equals to g of y curve. This is y equals to c. Again I'm telling you, y is equals to k is the line which is always parallel to x-axis. So this is 0. This is at a distance of c. And this is y equals to d. So here the area is bounded between x equals to g of y, this area. So x equals to g of y, and the lines y equals to c, y equals to d. This is y equals to c, this is y equals to d. So from three sides it is bounded except this, and y-axis is this now. Fourth is also bounded. So this area is nothing but area is equals to from C to D x dy. See here, C to D are the limits of y. Therefore, small change. If I take this will be dy. So, x is a function of y. Therefore, this is how much? C to D g of y dy. So, C comma D are the limits of y. Therefore, small change in y, and this is the function of y. So, this is how the situation will be. Likewise, the area of the region, sixth one, the area of the region bounded here, g of y is greater than 0 means for y-axis, as far as f of x equals to a, x equals to b, and x-axis is concerned. So f of x is this, x equals to a is this, x equals to b is this, and x-axis is this, and here f of x is greater than 0. That means f of x lies above x-axis. If we speak the x-axis in this situation, but if we take this situation, x equals to g of y with y-axis, so here this is above x-axis, below x-axis is minus f of x. F of x is negative. Likewise here, y-axis left hand side, right hand side is there, this is positive. Otherwise, if the area of the region bounded by the curves, same, x equals to, this is sixth one, x equals to g of y, where g of y is less than 0. Y equals to c, y equals to d, and y-axis is given by, this time the situation, the diagram of this will be like this. This is my x equals to f of g of y curve, and this is y equals to c, this is y equals to d, and this is my area now. Since this x equals to, this is x equals to g of y curve, x equals to g of y curve is this. So here g of y lies on the left hand side of y-axis. Right hand side of y-axis, g of y is positive. Left hand side of y-axis, g of y is negative. Therefore, area is equals to c to d minus x dy. Otherwise, c to d minus g of y dy. Before we start the sums of the area of the region bounded by the curves, so we need to understand the behavior of the various curves. Like we have so many curves, like y equals to mx, y is equals to minus mx, y is equals to mx plus c. Next, x by a plus y by b equals to 1. Y is equals to mx plus c. Okay. So, and these are what? Lines. Straight lines. And y square equals to 4ax. Y square equals to minus 4ax. X square equals to 4ay. X square equals to minus 4ay. These are parabolas. Standard form of the parabolas whose vertex is at the origin, and we have x square by a square plus y square by b square equals to 1. This is ellipse. So if a greater than b, x square by a square plus y square by b square is equals to 1. This is A less than B. So each one of these represents some different shapes. As far as y is equals to mx is concerned, we know that this is the line passing through the origin. So y is equals to, so here m equals to tan theta. Here theta is acute angle. So therefore the diagram of this will be y equals to mx. So here m is positive, theta is the acute angle, and y is equals to minus mx. That means the line will be passing through the origin like this same, but here mx, the negative slope represents m equals to tan theta. Tan theta is negative, means theta is obtuse angle, this much angle. And y is equals to mx plus c. This is also a straight line, but not passing through the origin. It may be like this, or it may be like this, whatever. And this x by a plus y by b equals to 1 is this x by a plus y by b equals to 1 is this line. Here A is the x-intercept, B is the y-intercept. So this equation of this line is x by A plus y by B equals to 1. Likewise, we have x by minus A plus y by B equals to 1 also. X by minus A plus y by B equals to 1. So plus plus minus plus. So it will be like this. So this is A, but this point is minus A comma 0. Earlier this is A comma 0 and this is 0 comma B. Here this is minus A comma 0 and this is 0 comma B. Or it may be either x by minus A plus y by minus B equals to 1. So the diagram of this would be like this. The diagram of this would be this. So this is minus A comma 0 and this is 0 comma minus B. So x by minus A plus y by minus B equals to 1. Likewise, we have another one, x by A plus y by minus b equals to 1. So it would be the fourth shape. Okay, and so otherwise it may be x by A plus y by minus b equals to 1. The shape of this would be like this. Shape of this would be, this is A comma 0 and this is 0 comma minus B. So this is B and this is X. So this equation is x by A plus y by minus B equals to 1. If I throw a stone like this, then actually it will obtain a shape like this. So that is, so if I throw a stone, it will go like this. The path of a projectile is a parabola. So you might have learned the properties of the parabola also in the chapter parabolas. So here, so this is y square equals to 4ax parabola, whose vertex is at the origin. So vertex is represented by A. So this is 0 comma 0. So what is vertex? The point of intersection of conic. Here parabola, conic and the principal axis both are intersecting at this point. And this vertex is at the origin. Then it is said to be the standard form of the parabola. So this is said to be the focus. Focus is a fixed point. So this is A comma 0 and this is the directrix L equals to 0. So if a point Z is to be taken here, then this would be minus A comma 0 So this is at a distance of A and this is also at a distance of A. Z, A, S are the collinear points. Okay. And y square equals to 4ax. This is the length of the latus rectum. So latus rectum we have known already. So latus rectum, see, this is the parabola. So this is the chord of the parabola. And if this chord is passing through the focus S, then it is said to be, this is chord. If this chord is passing through the focus, then this is called focal chord. And if this focus is, so this is another chord. If this chord is perpendicular to axis, principal axis, then this is said to be double ordinate. Double ordinate. And if this double ordinate, what is the double ordinate? The chord which is perpendicular to the principal axis. If this double ordinate is passing through the focus, then this is S now, and this is perpendicular. So this is said to be latus rectum. So this is chord. The line joining of the two centers of a parabola is said to be a chord. If this chord is passing through the focus, it is said to be a focal chord. And the chord which is perpendicular to the principal axis or simply axis, it is said to be the double ordinate. And this double ordinate which is passing through the focus, double ordinate means which is perpendicular to the principal axis and passing through the focus, is latus rectum. In other words, focal chord means it is passing through the focus. Focal chord which is perpendicular to the principal axis is also called latus rectum. So y square equals to 4ax. If y power even, this is symmetric about x-axis. This is x-axis. So this length, this as well as this are cutting into two equal parts. X-axis cuts the entire parabola into two equal parts. Y power even, it is symmetric about x-axis. So here x is symmetric about x-axis in the sense, it may be the parabola will be like this or like this also. So a confusion basically arises. But here x is positive. Therefore, it opens in the positive x-axis side. So let us try to draw the diagram of y square equals to minus 4ax. What is that? Y square equals to minus 4ax. So the diagram of this is, here its vertex is also at the origin. How? Because y minus 0 whole square equals to minus 4a into x minus 0. Here 0, 0 is the vertex. So the vertex, the parabola is said to be in a standard form if and only if the vertex is at the origin. So here y power even, it is symmetric about x-axis. Symmetric about x-axis in the sense, it may be open in the positive x-axis or a negative x-axis. Here x is a negative. Therefore, it opens in the negative x-axis like this. Okay. So he asks, what is the area of the region bounded by the latus rectum and the parabola? So actually he is asking us to find out the area of the region bounded by this curve. Okay. So one has to have a clear-cut understanding about the different shapes, behaviors of the curves. So this is a y square equals to minus 4ax curve. This is vertex A, which is 0, 0, and this is focus minus a comma 0, and this is a double ordinate. So L equals to 0. Double ordinate not. This is the directrix. Directrix is a fixed line. So this line is parallel to y-axis. Therefore, it is of the form x equals to k. So x equals to k means it is at a distance of, this is a. Therefore, this is also a. So this is x equals to a because this is a comma 0. Okay, and so far these two we have discussed. So now come to x square equals to 4ay. F is equals to 4ay. X power even, it would be symmetric about y-axis. Which y-axis? Y has a positive sign here. Therefore, the parabola will be like this. This is an upward parabola. This is an upward parabola. Its vertex is also at the origin. What is the vertex? The point of intersection of this parabola and the axis is this. So both are intersecting at this point. What is principal axis? Let us discuss this. S is equals to, this is, since this point is on the y-axis, so it would be 0 comma a. Any point on the y-axis, x coordinate is 0. It is at a distance of a units from the origin. So a, vertex a is 0, 0. So the line which is passing through the fixed point, which is a focus, is called, this is a principal axis. This principal axis and the parabola both are intersecting at this point is called the vertex, and this is the directrix. So if it is 0 comma a, this z will be of the will be 0 comma minus a because this is also a. So what is the equation of this line? This line is parallel to x-axis. Any line which is parallel to x-axis is of the form y equals to something. Therefore, y equals to minus a. And this is the latus rectum of this parabola. Likewise, x square equals to minus 4ay. So you just ask yourself like this. X power even, symmetric about y-axis. Which y-axis? Y has got a negative. So therefore, this is negative y-axis. X power even, symmetric about y-axis. That means this parabola is divided by this y-axis into two equal parts. So this x square equals to minus 4ay is the parabola, is a downward parabola. X power even, symmetric about y-axis. So y-axis cuts the parabola into two equal parts, and sir, x power even means symmetric about y-axis. It could be like this also, but here y has got a negative sign. Therefore, it would be a downward parabola. Likewise, x square by a square plus y square by b square equals to 1. This is a ellipse. That means the ellipse will be like this. This is a rough diagram of this ellipse. So here, this is center of the ellipse. If the vertex is at the origin, then the parabola is said to be in its standard form. If the center is at the origin, then the ellipse is said to be in a standard form. Here, this is said to be major axis and this is minor axis. Clearly, in this diagram, this is seemed to be longer with compared to this. Therefore, this is a dash, this is a comma 0, this is minus a comma 0. So this length of the major axis is, this is a and this is a, so length of the major axis is 2a. So length of the semi-major axis is small a. Likewise, b dash, this is 0 comma b and this is 0 comma minus b. This is b and this is also b. So length of the minor axis is B dash, which is 2B. Here A is clearly greater than B. So the ellipse will be like this. Okay, and A dash are the vertices of this ellipse, and here S comma S dash are said to be the foci. Parabola has a single focus. Here foci, F-O-C-I or F-O-C-I-I, foci or foci. So CS, the distance between the center and the focus is AE. Here also this is AE. So SS dash, this is 2AE, SS dash. So length between the foci is 2AE. The distance between the foci is 2AE. Likewise, this is one directrix, this is another directrix. This is L equals to 0, this is L dash equals to 0. This is Z, this is Z dash. This is A by E comma 0. This is minus A by E comma 0. So this would be A by E. This would be A by E. So the distance between the foci is 2AE. This is A greater than B case. So we have another ellipse which is of the form A less than B. Let us see that. So A less than B is this parabola. Here, this is x-axis, negative x-axis, y-axis, negative y-axis. So this is the center of the ellipse. This is S dash foci. This is B dash. This is A dash. This is A comma 0 minus A comma 0. Here clearly A is less than B. Here major axis is 2B. Length of the major axis is 2B. Length of the minor axis is 2A. And if we are about to find out the area of the ellipse, then let us see what will happen. See this here. This area. So area of the ellipse is pi AB. Okay. So pi AB. So here this is A and this is B. So here this is B. A greater than B. The area is pi AB. Here A is not equals to B. Now the area, because here this is A. This is A comma 0. This is 0 comma 0. This is center. So here A is equals to, from 0 to A, 0 to A, so 0 to A are the limits of x. Therefore here f of x dx. F of x means y dx. So here y square by b square equals to 1 minus x square by a square. So y equals to x square by a square. So b square by a square into. So if I write this y, this and substitute the limit, then actually pi AB is what we are getting. So into 4 if we multiply, then actually the whole area we will be getting, which is pi AB. So this ellipse to be a circle, so A not equals to B. If A equals to B, then this A and B will be same. Then it would be like this figure. It will be of this form now. So here earlier A greater than B, of course A is not equals to B, but here this is A and this is B, so B is equals to also A. That means here pi AB, here B is equals to A. B is equals to A if I substitute here, because here A is equals to B is the case. B equals to A if I substitute here, pi A into A, pi A square. So we all know that x square plus y square equals to A square. For the circle x square plus y square equals to A square, the area is pi A square. For x square plus y square equals to R square, pi R square. Here pi A square. So, and many more behaviors of the curves we will discuss in the next class.